Very good morning, students. Here we are dealing with the point architectural design. Unit architectural design, and in that, some software architectures we seen. In the previous lecture, we seen client server architecture, and today we are going to deal with the service oriented architecture. This is the second type of your software architecture. Now, in our software design and modeling subject, till now, basic concepts of software design and modeling, different UML diagrams we seen, and in this unit we started our design and its different architectures, how to design the software. In the very first, we seen the client server architecture, and now we are going to deal with service oriented architecture. Now, this service oriented architecture, service is acting as component of business functionality. Service are independent, self-contained, available to be used through programming interface. Now, this service oriented architecture is a client server architecture designed supporting business driven information approach, in which application consists of both software service and client or service requesters. Service oriented architecture provide many features such as distributed deployment, composability, interoperability, and reusability. Now, distributed deployment represents enterprise data and business logic. Composability add new processes from existing services. Interoperability share capabilities and reuse shared services across a new network irrespective of underlying protocol. Reusability allows to access the existing resources presented as services. Now, advantages. Advantages are increased scalability, increased reliability services, efficient in terms of time and cost, efficient and effective use of business services, integration is easier, improves interoperability of services regardless of the underlying protocol and platform. Now, next is design component based software architecture. Now, in this architecture, the design of the system is decomposed into individual functional and logical components. The decomposed components shows well-defined communication interface having methods, events, and properties. This architecture divides the problem into sub-problem, and every sub-problem is associated with individual component partitions. The decomposed component encapsulates functionality and behavior of a software element into reusable and self-deployable binary unit. Now, there are some standard component frameworks such as EJB, Java Bean, Corba, and .NET. These technologies can be used to desktop GUI application design, which can be reused. Component-based software architecture reduces time and cost by reusing existing components. It also increases reliability due to reuse of software component. Components here can be briefly described as modular, portable, replaceable, reusable software object that interact with other components. It encapsulates certain functionality. Advantages of this architecture is easy to deploy, reduce cost, it can be reusable, and it is reliable and independent. You can see here component 1, component 2, component 3, and extension point 1. From component number 2 component number 3, it is connected to component number 1 through extension point. Now, guidelines for design at component level. Separate the business process entities which are independent without any dependency or on other entities. It recognizes and discover this independent entity as a new component. Now, use infrastructure specific names that give idea about implementation specific meaning. If any dependency be found, model it from left to right and top to bottom, and model any component dependency as interface instead of showing it as component dependency. Now, how to design concurrent and real-time software architecture. First of all, it is time critical. Second, correct working of real-time system depends upon the output produced by the system and time at which the output is produced. Then real-time systems monitor such and control their environment and are mostly connected with hardware devices such as sensor and actuators. The system architecture of real-time software must allow for fast switching between stimulus handler due to the need to respond to timing demand. This architecture is mostly designed as cooperating process with real-time executive controlling this process. In this architecture, both software and hardware associate with the system. It divides functionality to hardware and software. Now, more about this is design decisions should be made on the basis of non-functional requirements. Then hardware mostly diverse between better performance but potentially longer development and less scope for change. Real-time system design process should identify the stimuli to be processed and required response due to stimuli. Associate concurrent processes to each stimuli and response and design algorithm to process this stimuli and response. Design a scheduling system that will ensure the processes will be scheduled on time. You can see here GI, communication, timer, control, this message, database, procedure at the center. Now to and fro communication from each is possible in this architecture. Now many real-time applications have been developed for the above architecture pattern, including satellite combat vehicle and controlling elementary particles, collider, then cruise control, instrumentation software, etc. Software correspond component mentioned in the above diagram can be mapped to concurrent task in multitasking structure design. They can also be mapped to traditional sequential structure design as well as object oriented design. Now here we will stop. In the next lecture we are going to see designing product line architecture, which is the next type of your software architecture. Thank you.